So we're trying to figure out what's the economic model to use, and we already put together one economic model, and this model is called the straight line model, where we're trying to allocate this cost over the service life. Well, let's see if we can come up with a different economic model just to kind of do a comparison. Okay. So again, we're trying to figure out what economic model. And we're going to use our same little, try and keep it similar. We're going to draw our little graph here. We're still going to have service life here. And again, we'll keep it time. We'll make sure that we'll try and keep a similar. We're going to use time. And then on the Y, this is our asset value or our costs. Okay, and we're going to have our beginning cost, our starting cost here. And we're going to have our residual value here. Okay. And we're still trying to figure out how to allocate this over a period of time. We're still trying to make that determination. And what if we think that in the early years, the value of the asset is going to get used up faster, and then the rate of change of use is going to kind of slide. So I'm going to try and draw this model first. So whereas we have the straight line method, we believe that it's pretty uniform. With a different method, we may judge that the early years, right? We're talking about, here's our beginning. That's 1 year, another year, another year, another year, another year, and then this is the end here. But we believe that the early years, there's more of that, more of the, we're using it up earlier. More of the value is going away earlier versus, say, the straight line method, which assumes that it just happens uniformly. So it looks a little like this. If we believe that the allocations of cost of whatever we ended up having here resembles this, then we've got to come up with a model or a formula to do that. And the steepness of this depends on the magnitude of, if we think it's really steep, then it should be a higher magnitude as far as a multiple of this straight line. If we think it's a shallower steepness here, then the multiple becomes less. So what we're saying here is that in 1 year, I'm going to take this much of an allocation here. That's a much bigger number, versus in this year, it's a smaller number, versus this year, it's an even smaller number, etc. Right? These are the amounts, right? These are the annual allocations. as I'm trying to bring this down, right? And you'll see that I actually drop a little bit below the residual value here in the way I write this. Because when we do this, this becomes asymptotic and it never actually goes to 0. So if I do this right, then I should get really close to the residual value. I may go over it, I may hover just above it. But I'm trying to model this in a way that makes sense, right? Again, this is also an estimate. So when we're trying to figure out the annual cost to allocate, we're going to take, and this is a little different, right? We're not going to start with the original cost. We're going to start with the book value of the asset. Okay? We'll always start with the book value of the asset. And this book value of the asset at the beginning of when we start is whatever the cost is. But the book value of the asset in year 2 is going to be this number here. So we're always moving the book value of the asset depending on which year we are evaluating this model. So we always start with the book value of the asset. And the way to calculate the book value of the asset is very simply the original cost minus the accumulated depreciation to date. Okay? How much I've already taken, right? This is the book value of the asset, this formula. So we start with the book value of the asset, and at the very beginning there is no depreciation. We haven't done anything, right? So on the very first year we're taking the original cost. Then we're going to multiply this times the straight line percentage. Right, so this is, I've got 1, 2, 3, 4, 5. I'm assuming this is 6 years. I think I use a similar 6 years. So this is, the straight line percentage is 1/6. So I'm going to take this book value of the asset times 1/6. Because that is, right, I can put this as a percentage, 1 divided by 6, and get the percentage. Or I can just multiply through by 1/6. And then I'm going to take the book value of the asset times this 1/6, and then also multiply it times a acceleration factor. How much that is hopefully going to model this. And this acceleration factor, right? This is a judgment, and this is a judgment. And so say we believe the acceleration factor is twice whatever the straight line rate is. Or maybe it's 1.5 times, or maybe it's 3 times, or 2.5. Your judgment. Let's start with, we think it's 2 times the straight line rate. That's our acceleration factor. I'm going to calculate this, and I'm going to create the amount of annual cost. Again, we call this depreciation. And then after I'm done with the first year, when I get to the end of the next year, then I'm going to take my new book value, which is my original cost, less what I've already taken for depreciation. That's my new book value. And then I'm going to still multiply by 1/6, which was the total useful life, times whatever acceleration factor I'm using. And unsurprisingly, this is referred to as accelerated depreciation. And it's an accelerated depreciation model. Right? This is an estimate. This lots of estimates going on in here. So let's try and make a comparison, actually do an example, make a comparison between this accelerated model versus our straight line model.